Alright guys, welcome to episode 1 of your SCHS Rocket Science SoundCloud review. In this episode we'll be going over all the different parts of a lab report. Okay, so without really any breaks, let's just jump right into it. The first section is the introduction and objective. In this section, you should probably have a summary of the background observations and research that led you to the question you want to answer or the problem you want to solve by doing your study, your lab activity, your experiment, whatever it was that you were doing. Okay. In this section, you should have at least your initial observations, summary of any research you've done up to that point, and then your question and your objectives. So basically, you're trying to tell me what were you trying to do in this experiment. All right. So if someone came into the classroom and they're reading your lab report, trying to figure out how to do this lab, they should have a pretty good idea of the overview of this lab. Okay, that's what goes in the introduction. Your observations, summaries of research, and questions and your overall objectives. This really goes for every single section, but you want to make sure you're as clear as possible. Remember, if you know something, I don't know you know it until you tell me. So the more clear you are with what you know, the better you'll do when it comes time to getting graded. All right, section 2. That's the hypothesis section. In that section, this is where the actual guess goes about your question or problem. Hypotheses can usually be written as if-then statements. Okay, so if I do this, then I expect this to occur. We spoke on how to find independent and dependent variables. So often, not always, but often, the if statement is going to be your independent variable. So if I change this, then your then statement would be your dependent variable. So then this will occur. Okay, so that was a pretty easy way to break down your hypothesis into if-then statements. For this particular experiment, the ManipulatAIRS Lab, you'll write the hypotheses that you tested in your different designs. And what I should see in this section is a overall change in your thought process. So your first test, you might put a hypothesis on there. I don't know, let's say you're doing the Tasmanian devil. And you thought, well, if we add a whole bunch of frilly pipe cleaners, then it will spin around really quickly. And then your independent variable would be if we add a bunch of pipe cleaners. Your dependent variable would be then it will spin around quickly. All right, but you want to show me how your hypothesis changed over time. So if that worked, then your next one might be, that worked really well. So we thought the next time we might add some more materials that were irregular that helped it spin around inside the tube. I don't know. You're going to have at least 3, hopefully more, hypotheses that you walk me through. Again, in your hypothesis section, you should be walking me through how your thought process changed over time as you refined your design and made it better suited to your task. So whichever vehicle you chose, if you chose the heavy lifter, the Tasmanian devil, or the rocket, you should be showing me throughout the whole section of the hypothesis that you are getting better at your design. So we tried this, it worked, and we tried this and it worked better, or we tried this and it worked, and then we changed something else and it didn't work so well, so we had to go back and change that. Okay, materials and equipment. In this section, you list all the things that you need for your experiment. So everything that's available to you. Remember, if you have some person coming out off the street or a new student to this classroom and they want to know how to do this lab, they need to know everything they have available to them. The most common mistake that I saw in this part of the lab report was many people put just what they used for their particular design. So keep in mind, materials and equipment, you always list everything you had available to you. All right? So be sure to go back and think about what you had open, the straws, the pipe cleaners, the popsicle sticks, and don't forget, you need a wind tunnel, right? And a fan. In the procedures section, you need to list in order the steps of your study or experiment. So describe in sentences how you're going to collect that data. Remember to be clear. All right, so explain things as if you're explaining them to a person who had never seen this experiment before. You are explaining how this experiment goes, step by step. So don't forget that I had to stamp your design to get approval, and then you were going to build it. Okay, I'm not going to go step by step and give you everything, but remember to be clear and go step by step from the very beginning until the end, everything you did in this experiment for your procedures. In the results section, you're going to put your observations, your calculations, and your analysis. All right, so in this section, you're going to display and analyze all the data that you collected. You should also write down what happens as you do your experiment or study. So include any formulas you use, diagrams, pictures, data tables, graphs, anything that's graphical data that we can use goes in the results section. So be sure to show any calculations you made, talk about what actually happened in your experiment, so what your data showed, include specific examples. For this particular experiment, you're going to use the data that you have in the back of your design sheet. So it was like how many pennies you carried if you're a heavy lifter, how long it stayed in the tube if you're a Tasmanian devil, and how many pennies you could carry out of the tube if you were a Shelby County rocket. In the conclusion, you want to restate the purpose of the experiment. So talk about what you learned by doing the study. It'd be a good idea to include specific examples of data analysis when it's appropriate, and maybe include whether or not your hypothesis was correct with an explanation of why or why not. All right. A real scientist would state what might have gone wrong and when the results weren't what they expected, or how they could improve the study next time. I would expect you to do the same thing. Remember, I don't care if it failed or if it didn't work. I care if you can't explain or can't reflect on why you think something didn't work. Failures are going to happen in experiments, and that's okay. That's how we learn. But if you can't think about why it might have failed and can't elaborate on what your thinking is, then that's a worse failure. So again, if it fails, that's okay. You need to explain why you think it failed in depth. Give me some really good thoughts there. Also include what you do next. So maybe modify your hypothesis, change it completely, do another study of the same hypothesis, try it over again. If your hypothesis was proven correct, your ending might be a statement of further questions you have now, or studies you could do that relate to your topic. You might want to end with how this study applies to real-world problems. Again, we try to keep our labs pretty close to real-world situations, things you can work on. Again, I'm really big on you being able to take tools out of 8th grade science and apply them to the rest of your life. So just an overall thought, you might want to think about how this applies or how you can learn some lessons that you can apply to real life. Alright guys, that about wraps it up. Again, you can look on SoundCloud for my comments. I'm putting a comment to each individual section so you can skip back and forth as you need to. Alright, looking forward to seeing your lab reports or your resubmissions. Again, please come back and review this anytime we have a lab report if you need to, if you so desire. Looking forward to seeing you guys in class. I'll talk to you later.